discovery in Antarctica. Researchers find new life under an ice shelf, and the discovery was an accident.
Antarctica, the frosty frontier at the bottom of the world, holds an array of disturbing discoveries that add layers of intrigue to its ice-encrusted landscapes. Among these numerous enigmatic findings, 10 in particular stand out for their unnerving implications, made more chilling by their unearthment by Russian scientists. Number 1. The Lake Vostok microbes. Delving into the dark and mysterious underbelly of Antarctica, we find ourselves at Lake Vostok, an ancient freshwater lake buried beneath over 2 miles of solid ice. The lake, which has been isolated from the rest of the world for over 15 million years, possesses a disconcerting secret: strange, unidentifiable life forms. Russian researchers managed to drill through the thick ice cover in 2012, penetrating the icy layer and reaching the lake's ancient waters. Their objective was simple: to retrieve samples that could unlock secrets of past climates and perhaps reveal if life could exist in extreme environments. What they found, however, extended far beyond their initial expectations. The team discovered numerous microbes, of which many could not be classified into any existing bacterial or archaebacterial phyla. These strange organisms had developed and survived in total isolation, within extreme, cold, complete darkness, and under immense pressure, providing an environment that one would deem hostile to life as we know it. The Lake Vostok microbes have since posed more questions than answers. The discovery of Lake Vostok's microbes has further sparked fears about the potential implications of climate change. As global temperatures rise, glaciers melt, potentially releasing ancient, unknown organisms back into the world's oceans. The impact of these ancient microbes on today's ecosystems is hard to predict, but could have potentially catastrophic effects. Moreover, there is the unsettling thought of what could happen if such organisms made their way into human populations. The likelihood of an Andromeda strain-like scenario, as posited by Michael Crichton, where an ancient or extraterrestrial microbe causes a deadly pandemic, may seem far-fetched. However, the existence of such strange, unclassified organisms in Lake Vostok reminds us that our understanding of life on Earth is far from complete. Number 2. The hidden subglacial mountains. Antarctica is often visualized as a flat, barren landscape, characterized by its vast expanses of ice and snow. However, the terrifying discovery of an entirely hidden mountain range, lying subglacial and concealed from the outside world, shatters this common perception. Russian explorers, in collaboration with international scientists, used radar technology to map the Antarctic bedrock in the late 1950s. During this expedition, they stumbled upon a bizarre and unexpected topographical anomaly, a series of peaks and valleys deep beneath the ice, now known as the Gamburtsev subglacial mountains. These mountains, which are as high as the European Alps, exist entirely beneath the East Antarctic ice sheet. Completely concealed by ice, these mountains had gone unnoticed and unexplored for centuries. This range isn't just significant for its size or the fact it's hidden. It's also believed to be one of the most ancient mountain ranges on the planet, existing for over 500 million years. The discovery of the Gamburtsev Mountains challenges conventional scientific wisdom about the nature and formation of mountain ranges. As per geological understanding, mountains of such antiquity should have eroded away millions of years ago. Yet, the Gamburtsev Mountains remain standing tall, preserved under the thick ice, contradicting our comprehension of erosional processes. The Gamburtsev Mountains have also been likened to ghost mountains, and for a good reason. They exist as an eerie, unseen presence beneath the ice. Any attempt to study them must be done indirectly, using methods like ice-penetrating radar or seismic surveying, making the mountains a spectral entity that can be detected but not directly observed. The inherent uncertainties and unknowns surrounding these subglacial mountains make them a source of both scientific fascination and fear. There's much to learn from the Gamburtsev Mountains about Earth's geological past and the potential future implications of climate change. But at the same time, the mystery surrounding these ghost mountains, their formation, preservation, and the secrets they hold, brings with it a sense of unease. Number 3. The ancient meteorites. Antarctica, a vast white canvas, has proven to be a treasure trove of meteorites, ancient fragments of asteroids or comets that have fallen to Earth. Due to the white backdrop and lack of terrestrial rocks, meteorites are easier to spot on the ice, making Antarctica a prime hunting ground. However, it's the age and origin of some of these meteorites discovered by the Russians that add a terrifying twist to these otherwise mundane space rocks. Russian researchers have discovered some of the oldest known meteorites in Antarctica. One of these, designated as ALH 84001, is believed to have originated from Mars, ejected from the planet's surface during a violent asteroid impact. What makes ALH 84001 particularly remarkable and somewhat disturbing is the controversial claim of potential fossilized Martian bacteria within it, raising the possibility and the fear of life beyond Earth. Despite years of ongoing debate and studies that cast doubts, the notion of potentially discovering extraterrestrial life, albeit fossilized, poses a terrifying proposition about our place in the universe. It forces us to confront the reality that we may not be alone, raising unsettling questions about the nature of life beyond Earth, the potential for microbial contamination of planets, and the broader implications for astrobiology. Another meteorite of note discovered by Russian scientists in Antarctica is an example of an L-chondrite. This type of meteorite originates from an enormous asteroid collision that occurred approximately 470 million years ago in the main asteroid belt between Mars and Jupiter. The terrifying aspect of this discovery lies not in the meteorite itself, but in what it represents: a catastrophic cosmic event of unimaginable scale. Furthermore, the discovery of these meteorites illuminates the unsettling fact that life on Earth is intrinsically linked to the cosmic ballet that unfolds in the vast expanse of space. It is a chilling reminder of the potential dangers that lurk in the cosmos and the continual threats faced by life on Earth from beyond our atmosphere. Number 4. The Blood Falls. One of the most visually startling and unsettling discoveries in Antarctica is the Blood Falls, a flow of iron-rich, salty water that stains the ice with a blood-red hue. Uncovered by Russian explorers in the early 20th century, the Blood Falls presents a surreal and somewhat gruesome spectacle in the otherwise pristine white landscape. The falls, emanating from the Taylor Glacier in East Antarctica, are fed by a subglacial lake containing high concentrations of iron. When the iron-rich water contacts the air, it oxidizes, turning red and creating the startlingly blood-like appearance. The existence of such an alien-like feature within Earth's polar desert is a chilling reminder of Antarctica's strange and mysterious nature. However, the unsettling nature of Blood Falls extends beyond its eerie aesthetic. The falls offer insight into a hidden ecosystem that exists beneath the Antarctic ice, surviving in extreme conditions. In 2009, scientists found that the salty water within the falls hosts a variety of extremophilic microbes, organisms that can survive and thrive in harsh conditions that would be uninhabitable to most life forms. These microbes exist in an environment completely cut off from sunlight and oxygen. They survive by using iron and sulfur in the water for their metabolic processes, a form of chemosynthesis. This eerie ability to survive in such extreme conditions triggers a disconcerting realization about the potential for life to exist in environments previously considered too harsh. Like the Lake Vostok microbes, the organisms in Blood Falls challenge our understanding of what constitutes a habitable environment and broaden the scope of where life might exist elsewhere in the universe. This knowledge, while fascinating, is also somewhat unsettling, opening the door to a realm of possibilities about alien life that humanity may not be prepared to confront. Moreover, the ecosystem of Blood Falls serves as a reminder of the potential consequences of climate change. As global temperatures rise and Antarctic ice begins to melt, more of these extreme environments may be exposed, releasing their microbial inhabitants into the oceans. The impact that such ancient organisms could have on today's ecosystems remains unknown and is a cause for concern. Lastly, Blood Falls reminds us of the past climates of Earth. The briny water is believed to be a remnant from the sea that was trapped and isolated some 5 million years ago. This insight into our planet's past climate conditions is a chilling reminder of Earth's volatile climate history and the potential for drastic change in the future. Number 5. The Gamburtsev Mountains' Secrets. Earlier, we explored the eerie existence of the Gamburtsev subglacial mountains, a sizable and ancient mountain range lying beneath the East Antarctic ice sheet. However, the unsettling aspects of these ghost mountains extend beyond their mere existence. Delving deeper, one uncovers mysteries and secrets associated with these subglacial mountains that further amplify their terrifying aspect. One of the most intriguing and chilling aspects of the Gamburtsev Mountains is their formation. As per our understanding of mountain-building processes, their existence makes little geological sense. The region where the mountains are located is situated in the middle of a tectonic plate, which is unusual because mountain ranges generally form along tectonic plate boundaries where they collide or slide past each other. The mystery deepens with the knowledge that the mountains are believed to be older than the ice sheet itself. As per the current theories, the Gamburtsev Mountains likely existed before the formation of the Antarctic ice sheet, which is about 34 million years old. However, the exact age and geological history of the mountains remain largely unknown, adding to the enigma. This uncertainty, combined with the strange and unexplained topography of the mountains, raises a series of unsettling questions about our understanding of Earth's geological past. It poses challenges to established theories about how mountains are formed and how they evolve over time. This, in turn, highlights our limitations in understanding the planet we inhabit and adds an unnerving element to our comprehension of Earth's geology. Another unnerving aspect of the Gamburtsev Mountains is the presence of liquid water in the form of subglacial lakes and rivers beneath the ice sheet. These lakes are kept liquid by the heat from the Earth's interior and the pressure of the overlying ice. The existence of these water bodies in such a cold and inhospitable environment is both fascinating and somewhat disturbing. These subglacial lakes and rivers have been isolated from the rest of the world for millions of years. As such, they may harbor life forms that have evolved independently, much like the microbes discovered in Lake Vostok. The potential existence of such extremophiles presents the terrifying prospect of encountering unknown organisms that could have significant implications for our understanding of life on Earth and beyond. Furthermore, the Gamburtsev Mountains hold secrets about the past and future of Antarctica's ice. The valleys and ridges of these mountains influence how ice flows and accumulates, affecting the stability of the ice sheet. As such, the mountains play a significant role in predicting how Antarctica's ice will respond to climate change, a prospect that could have severe global impacts. Number 6. The extreme radiation levels at Vostok Station. In the heart of the Antarctic ice sheet, Russia operates the remote Vostok Station, a site that plays host to a rather unsettling and less-known Antarctic discovery: high radiation levels. The intensity of the radiation at Vostok Station is a frightening reminder of the hostile conditions that can exist on Earth and potentially other planets, challenging our understanding of habitability and survival. The high radiation levels at Vostok Station are primarily due to its high altitude and proximity to the Earth's magnetic poles. The combination of these factors makes this location particularly vulnerable to cosmic radiation, particles that originate from the Sun and other celestial bodies outside our solar system. When these high-energy particles collide with atoms in the Earth's atmosphere, they create a shower of secondary particles, leading to increased radiation levels. The radiation level at Vostok Station is so high that inhabitants at the station receive an annual dose that exceeds the limit recommended for workers in the nuclear industry. This prolonged exposure to high levels of radiation poses a serious health risk, including an increased risk of developing cancer. What makes this discovery particularly terrifying is that it serves as a stark reminder of the extreme conditions that humans may face as we explore more of our universe. As we plan for future manned missions to other planets and potentially habitable moons, understanding the effects of high radiation levels on human health becomes critical. The Vostok Station, in essence, provides a glimpse of the extreme conditions that might be faced in off-Earth colonies, particularly on bodies without substantial atmospheres, such as Mars or the Moon. Moreover, The high radiation levels at Vostok Station give us a terrifying insight into a post-nuclear world. In the event of nuclear war or a nuclear disaster, the radiation environment at Vostok could be a grim preview of what large parts of the world might experience. In addition to human health implications, high radiation levels can significantly affect technological instruments and devices. Equipment failure due to radiation damage is a common problem at the station, signifying the technological challenges that extreme radiation environments pose. Therefore, the increased geyser activity at Yellowstone presents yet another reason why the supervolcano could potentially erupt at any time. It serves as a reminder of the active and volatile nature of Yellowstone's geothermal system, which is directly linked to the simmering magma reservoir beneath. A close observation of these geothermal marvels is therefore imperative to understanding and potentially forecasting Yellowstone's volcanic behavior. Changes in hydrothermal reservoirs. The hydrothermal reservoirs of Yellowstone National Park are large underground systems containing hot water and steam, created by heat emanating from the magma chamber. Any changes in these reservoirs can be indicative of alterations in the deep geological processes, offering further insight into the possibility of an imminent volcanic eruption. Hydrothermal reservoirs play a crucial role in Yellowstone's geology, directly influencing the park's extensive network of geysers, hot springs, mud pots, and fumaroles. Changes in these reservoirs can manifest in several ways, including alterations in the temperature and chemistry of hot springs, new or reactivated thermal features, and increased geyser eruptions. One of the most significant changes that can occur in a hydrothermal reservoir is an increase in pressure. This can be caused by an influx of magma into the chamber, a rise in the heat supplied by the magma, or seismic activity creating blockages in the plumbing system. The increased pressure can lead to more frequent or intense geyser eruptions and other changes in geothermal features. Another way changes in hydrothermal reservoirs can be detected is through water chemistry. The heated water in these systems dissolves minerals from the surrounding rocks. As such, the mineral content of the water in geysers and hot springs can offer clues about changes in the hydrothermal system. A sudden or substantial change in water chemistry could signal a disturbance deep within the reservoir. The Norris Geyser Basin provides a notable example of changes in a hydrothermal reservoir. The ground level in this region has been rising rapidly over the past years, a phenomenon linked to changes in the hydrothermal reservoir beneath. This uplift, coupled with increased geyser activity and changes in the water chemistry of local hot springs, suggests significant changes in the hydrothermal system, possibly related to the movement of magma. Monitoring the hydrothermal reservoirs is a complex task, requiring a combination of ground-based observations and satellite imaging. This data, when coupled with seismic information and ground deformation measurements, can provide a comprehensive picture of the state of the hydrothermal system and its potential implications. Anomalous gas emissions. Volcanic gas emissions provide important insights into the magmatic processes occurring beneath the surface. In Yellowstone National Park, the monitoring of gas emissions, particularly carbon dioxide, CO2, and sulfur dioxide, SO2, is a critical component of assessing the state of the underlying magma chamber. Anomalous or sudden increases in these emissions could signal changes in the magmatic system, potentially indicating a forthcoming eruption. The bulk of gases emitted by Yellowstone are water vapor, steam, and carbon dioxide, with minor amounts of sulfur gases and other trace elements. These gases originate from the magma, escaping to the surface through cracks in the Earth's crust and the park's geothermal features. CO2 is the second most abundant gas emitted by volcanoes, and its levels can hint at changes in the magmatic system. Yellowstone emits a substantial amount of CO2, with estimates suggesting that about 45,000 tons of the gas are released every day. A sudden or significant increase in CO2 emissions could indicate an upwelling of magma, as fresh magma releases more CO2 compared to the older, degassed magma. SO2 is another key volcanic gas. While SO2 emissions at Yellowstone are generally low due to the extensive hydrothermal system scrubbing out most of it, any significant increases in SO2 levels could suggest new magma entering the system. Monitoring these gases involves ground-based measurements and satellite observations. Ground-based instruments like gas sensors and spectrometers measure gas concentrations directly. In contrast, satellites can provide a broader view of gas emissions across the park. Combining these measurements allows scientists to track changes in gas emissions and identify potential anomalies. Changes in gas emissions were observed during periods of increased seismic activity and ground deformation at Yellowstone, suggesting a connection between these events and the subsurface magmatic processes. Furthermore, the sheer age of the ice is a sobering testament to the persistence of Antarctica's ice sheets. To think of ice persisting for 1 million years is awe-inspiring but also deeply unsettling when considering the current rate at which we are losing it. It puts into perspective the scale of human-induced climate change and the potential impact it could have on these ancient ice sheets. Number 9. The giant crater beneath the ice. Hidden beneath the ice in East Antarctica, Russian scientists have unveiled an immense and chilling discovery: a giant crater. The existence of this massive depression, carved into the Earth by a powerful event, brings to light the destructive forces that our planet has endured, as well as the potential for such cataclysmic events to occur in the future. This enormous subglacial crater, known as the Hiawatha Crater, is more than 19 miles wide and was likely created by the impact of a massive meteorite. The collision would have released energy equivalent to millions of nuclear bombs, causing widespread destruction and potentially leading to significant shifts in the Earth's climate. What's terrifying about this discovery is the scale and potential consequences of such an impact event. The meteorite impact that created the Hiawatha Crater would have been a global catastrophe, causing massive wildfires, tsunamis, and a nuclear winter scenario where dust and debris block out the sun, leading to a sudden drop in global temperatures. The discovery of the Hiawatha Crater also serves as a stark reminder of the threat posed by near-Earth objects, such as asteroids and comets. While significant efforts are being made to track these objects and mitigate the risk of an impact, there is still a potential for such a disaster to occur. This lingering threat is an unnerving aspect of our existence on this vulnerable planet. Moreover, the detection of this crater challenges our understanding of the Earth's history. The age of the crater and its potential connection to mass extinction events or significant climatic changes are topics of ongoing research. This adds an element of mystery and uncertainty to the already daunting nature of the discovery. Finally, uncovering the Hiawatha Crater involved overcoming significant technical challenges, as it is hidden beneath a mile of ice. The use of advanced radar techniques to reveal this hidden scar on the Earth's surface emphasizes the fact that we are still in the early stages of exploring and understanding our own planet, particularly the remote and harsh environment of Antarctica. Number 10. The disquieting warming trends. In the coldest place on Earth, Russian researchers have been tracking a trend that is as disquieting as it is significant. Antarctica is warming. This temperature increase, particularly notable in West Antarctica and the Antarctic Peninsula, has implications that extend far beyond the icy continent, threatening global climate patterns, sea levels, and the myriad forms of life that inhabit Earth. The warming trend in Antarctica has been confirmed by several different data sources, including weather stations, satellite measurements, and ice core samples. These sources have shown a marked increase in both surface and subsurface temperatures, with some areas of Antarctica warming by more than 2.5 degrees Celsius over the past 50 years. This rapid warming is having a visible and alarming impact on Antarctica's ice. The ice sheets in West Antarctica and the Antarctic Peninsula are losing mass at an increasing rate, contributing to global sea level rise. Additionally, warming oceans are eroding the underbelly of the ice shelves, leading to an increase in iceberg calving. One of the most unnerving aspects of these warming trends is the potential for reaching tipping points that lead to irreversible changes. One such tipping point involves the potential collapse of the West Antarctic ice sheet. If destabilized, this ice sheet could raise sea levels by several meters, flooding coastal cities and displacing millions of people worldwide. The warming trends in Antarctica also have profound implications for local and global ecosystems. The loss of sea ice is likely to impact krill populations, a keystone species in the Antarctic food web. Changes in krill abundance will affect all higher levels of the food chain, including whales, seals, and penguins. Globally, the changes in Antarctica can influence ocean circulation and weather patterns, potentially leading to more extreme weather events. Furthermore, the warming of Antarctica could lead to the release of large amounts of methane trapped in the permafrost and beneath the ocean floor, contributing to a feedback loop of further warming. This methane release could significantly accelerate global warming, leading to drastic and unpredictable changes in climate across the planet.